Hello, in this video we're going to work through this example problem here. So in the diagram below, DA is perpendicular to AB, and BC is perpendicular to AB also, AB. So we get a 90-degree angle there and a 90-degree angle there. So then it tells us that angle ACD is 90 degrees. We know that AC is 6, AD is x plus 5, BC is x. We want to find x. So one of the challenges of this problem might be figuring out what mathematical technique to use. Now, of course, if you happen to be studying a unit on similar triangles and you've got this problem, the suggestion would be to start with similar triangles. But at the same time, one of the things that's hard about this is seeing what technique to use. Some students might try and jump in and use some trigonometry because we have right angled triangles here. So I will tell you this does come from a unit that covers similar triangles, but even if I didn't know that, the first thing I would do with this problem is I'd try and identify angles that are the same and look for similar triangles. So if we look here, we know that this angle here, angle BCA, we have a Z pattern here. It's going to be the same as angle CAD, and if angle B is 90 degrees here and angle ACD is 90 degrees and these two angles are the same, that means that angle CAB is the same as angle ADC. So what we see here is we have a similar triangle situation. So I want to state that. So I'm going to state that triangle ACD is similar to triangle. And now this is very important. We want to match up angles. So if we're talking about triangle ACD here, and that's the angle with a single dot, the other triangle starts here. So it's going to be similar to triangle C. We go A, and then we go to the 90-degree angle, BA. Okay, it's a little idea, but it's very important. Make sure when you're making your statement about similarities that you match the angles accordingly. So now what we're going to do is I want to solve for x. So one way to do this is, well, if I want to solve for this x here, I'm just going to take this x and put it in the numerator, and I have x over 6. So I've taken two sides from triangle ABC. So now I'm going to look at the other triangle, and I have to take the two similar sides. So x is the side that travels from the dot to the 90. So the dot to the 90 in this case is 6. And then 6 is the length in triangle ABC that travels from the two dots to the single dot. Two dots to the single dots is the x plus 5. And what I see now is I have one equation with one unknown. So what I want to do is get x by itself. So the first technique, what I want to do here is I want to get rid of the x plus 5. I want to get that out of the denominator. So what some people will say here is they'll say you cross multiply. You take whatever's in the bottom here and you multiply it by the top. We'll take whatever's in the bottom here, multiply it by the top, which will work. But I always like to make sure I know the mechanics of what's going on. So I'm going to write it a little bit more here to make sure we see and understand the mechanics here. So what I want to do is first get the x plus 5 out of the denominator. So I'm going to multiply both sides by x plus 5. And what happens then is these two cancel out. So what I end up with is x times x plus 5 over 6 equals 6. And now what I'm going to do is I'm going to multiply both sides by 6. And then when I multiply both sides by 6, these cancel out. So I get x plus 5 is equal to 36. At this point I stop. And I think, okay, well now I have one equation with one unknown. That's a little easier to solve for. So if I expand this, what I notice is that I have a quadratic. Remember, a quadratic we can't necessarily isolate for x in the traditional way. So we want to get it in its special form. That is ax squared plus bx plus c equals 0. So I have x squared plus 5x minus 36 equals 0. And I can factor this, so I say two numbers that multiply to minus 36, but I had to give me 5. So I know it's going to be x and x here. So my numbers are 9 and 4. So the question is which is positive and which is negative. Since x here is positive, this is going to be plus 9 minus 4. So now we have to look at each of these brackets. So x could equal negative 9 and x could equal 4. Now I'm going to ask myself, well, which one of these, do they both make sense? And of course x can't be negative because it's a length. So therefore that's invalid. So our only answer is x is 4. I hope that helped.